Let's move on and provide an overview of concurrency and locking. Let's say there are several applications, application A, B, C. And D, trying to access the same row in the same table. Now, if there was no concurrency control, then you may have that all of these applications could be doing an update on this same row at the same time. So, at the end, what will be the final result? It would be hard to tell. Concurrency in general means that several applications can work at the same time on the same database or same tables on the database while keeping the data consistent. Locking is how a database management system can ensure data integrity and consistency. So, in this example, if application B is the first one to perform the update on the second row, it would immediately take a lock on the row, and the other applications would have to wait until this lock is released. Locks are normally acquired automatically for you based on isolation levels that you can set. Isolation levels are like policies on how locks are taken and will be detailed later on. As mentioned earlier, a commit or rollback statement will release all locks on a row. There are several types of locks in DB2. For simplicity, we only show the main. Two, an S-lock for sure is taken when you perform read operations such as when using a select statement. An X-lock for exclusive is taken when you perform operations such as a delete, update, or insert. Concurrency allows user to access a database simultaneously so that several applications can work on the same database at the same time. While the data remains consistent, there are several problems that can happen if there is no concurrency control. The 4 problems that can happen are loss, update, uncommitted, read, non-repeatable read, and phantom read. We explain each of these problems in more detail next. Let's use the following example to explain the loss update. Problem in this example, say you have a table called reservations which has the column seat, the column name, and so on. Now say application A updates the table reservation so that the name for seat 7C change to John. Now assume there is another application B at the same time is trying to do the same but using the name Mary. Assuming application B issued the update slightly later than application A, the last value for the name would be Mary, which means that the first update from application A was a loss. Loss update. If we repeat the same process again, but this time application B performs the update first followed by application A. In that case, the last value for the name would be John and the first update from application B would be lost. So basically, without some type of control, we would lose an update from the first application. To explain the second problem called uncommitted read, let's use the same example as before. Application A performs an update so that John is the name that corresponds to seat 7C. Next, application B issues a select which would retrieve the name of this same record so that output is John. Next, application A issues a rollback, which means any changes made would be discarded, so the corresponding name for seat 7C is back to null. If application B continues further processing using John, it's actually using data that was not committed and is incorrect. This problem is called uncommitted read. Let's move on to another problem called non-repeatable read. In this example, we have the same reservation table and the same application. Application A is this time issuing a select statement which retrieves two seats 7C, 7B, then application B issues an update. So seat 7C is assigned a passenger with name John, when application A within the same transaction issues another select which is exactly the same as the first one it had issued. This application will now get one seat 7B, so it's not a repeatable read. Issuing the exact same select statement within a transaction leads to different results. Now let's talk about the last problem called phantom read. Assume the reservation table has passenger Susan assigned to seat 7C. When application A executes a select to retrieve all seats not assigned where name is null, it will return only one value, 7V. Next, application B updates seats 7C setting the name to null. If application A executes again the exact same select statement, within the same transaction, it will now retrieve two rows 7C and 7B. So in this case, the select statement in the same transaction is retrieving one more row, a phantom row. This is why this case is called phantom read. It is very similar to a non-repeatable case. In non-repeatable read, you get less rows, while for phantom read, you get more rows.